Can anybody verify that the live is okay, that you're able to see me?
Yes.
Okay, thank you. Okay, Chris.
Great.
And
well, yeah, well, great to be able to talk to everybody today. This is actually a talk that I've titled Prototyping Machine Learning and AI Using Design Sprints. And so this was a talk that I gave at Agile Alliance 2019, which was in, I believe, September in Washington, DC. And that audience was mostly interested in what is the nuance around AI and machine learning when it comes to using design, like in the format of design sprints, because that's something that's very familiar to them. I think I wanted to use this as a conversation piece because it has a lot to do with the work that I did previously to my time at IPsoft. But anyways, this is my email address and that's my Twitter handle if you want to say anything nice about me online.
We'll say wonderful things. Sorry, 1 second, Chris. Yeah. For anybody joining us on YouTube, this is Chris Butler, and he's an expert in machine learning UX. And he's going to be talking to us. Obvious slide presentation is here. And we have the AIX class right here, and they are the ones who get to ask questions this time. So let's get started.
Great, I'm looking forward to it. Well, yeah, so when we talk about what is prototyping machine learning and AI, especially when it comes to the user experience side of prototyping, I'm actually not talking about prototyping as far as the models, but like how do people actually access these systems in some way? And from my perspective, it's really like faking fake things to be less fake, right? So how do we know what's the right thing to build before we actually go and gather all the data, clean it, and then train models, things like that. So this is my background. I didn't put Dash on here just because it was only for like a short 9 months. But I have worked for companies like Microsoft, Waze, Horizon Ventures, Kayak, and then Philosophy, which was a design consultancy where I was director of AI and director of product strategy. And so that's where the main case study is going to come from here. But currently I'm a chief product architect at a company called IPsoft. We do a lot of large scale IT management and services. But what I work on in particular is our platform that's called Amelia, which is a conversational agent. So how do you get really large scale IT systems to be accessible by regular employees or regular people in a B2C context so that they can ask it questions and get it to do something that they need to do. In this talk, I'm going to go over a few different things. I'm going to give you a really, really brief how I kind of define AI, machine learning, and data science. We're going to talk about sprint methodology if you're not familiar with it. I'm going to show you a case study that I'll interleave through the entire set of steps, a tour of techniques and workshops I've used when doing this type of prototyping. And then finally, what you're going to take away from here is really how to prototype AI or machine learning systems in a particular sprint context. Because I think there's a lot of people that say that you cannot actually build these types of systems in a way that is very iterative, and I would disagree with them. So that's what this talk is going to be about. So first of all, what is AI? And I like to start, we'll try to do it in less than 5 minutes actually. And let's start with what it is not, right? First of all, it's not just chatbots. It's not just conversational agents. It's not just things that you can talk to. That's a way to interface with different types of machine learning algorithms like, NLP, NLU. The next thing is that it's not magic fairy dust that you can just sprinkle on any project and suddenly it gets better. It's not probably going to kill us anytime soon. At least all of us. There are real issues around bias and ethics that we should talk about or at least reference at some point during this talk. It's not something we're going to fall in love with. And then I like to use this because this is really the perception or the way that people level set when it comes to AI. So if you type in AI into Google image search, this is what you're going to see. And this is not the reality of the way things actually work, right? It's not big blue glowing brains. It's not white plastic robots. It's something where it's really more about an ecosystem, and I'll talk about that. And then finally, it's not always when we talk about automation, something that is really intelligent, right? These are systems that are available in, CVS's, Dwayne Reed's, any type of convenience store or supermarket you go to, where it's really self-checkout. And this is a type of automation, but it's not necessarily intelligent. This is built with systems that have, technologies that have been around for 10, 20 years, possibly. And so this is about offloading certain tasks or automating certain tasks in the end. So what is it? I really like this, this particular definition by David Robinson, who's a chief data scientist at DataCamp, which is another great place if you want to learn the nuts and bolts of actually developing things like data science, machine learning. But data science is really about producing insights. Machine learning is about producing predictions, which really are like classifications. And then AI in general is about producing an action. And you're going to use a combination of these things in any one of your projects. And so I like to talk about all of them together because I feel like when we talk about just AI, we get into a very hand-wavy place about what we're talking about. But I like to include data science, machine learning, because those are kind of other technologies that fit in here. Even though machine learning is maybe a sub-tribe of artificial intelligence, I think it's important to talk about really the way I think about these three different things. And when we start to talk about why we're talking about prototyping, is because we want to really build things that are human-centered in some way. And so I would take this definition again, and I would add people to it, right? So data science is about producing insights about people in some way. Machine learning is about producing predictions for people to use in some way. And AI, in the end, is to produce some action that helps people. It's not about the system just going off and doing things on its own, right? It's about people in the end. The next thing, since we've kind of rushed through the AI thing, I'm sure you're doing lots of work and research into what AI, all the different types of AI or different types of machine learning. But the sprint may be something that people are less familiar with. And so the sprint comes from Google Ventures, and where they had created basically a methodology where within a week you can go from problem identification to a prototype that's been tested with people. And so something I think is really powerful, and I think it's really valuable when it comes to how do we quickly understand a problem and then build something for it. And the way it's broken up is into really 5 major steps, which are supposed to take up 1 day of the week if you do a 1-week sprint. And so the first one is map, which is really, how are you understanding the problem? How are you understanding the particulars of the problem? Sketching, which is, what are all the possible ideas to solve that problem that you're identifying? Decide is where you, rather than say sketch is convergence of maximum number of ideas, deciding is about convergence into a particular problem. Thursday is about prototyping, so building something very simple, very fast, where on Friday you can then test it with real people. And so this is the sprint methodology if people are not familiar. Something I've used many, many times. I've also used design thinking, which is another 5-step process by D-School to talk about this. But I like the sprint methodology in this case. But I've also done very long, like 3-hour-long workshops and tutorials around design thinking for AI. And it's a similar framework. I found it to be pretty simple. So yeah, so we're going to talk about a particular case study. And this is around FSO, which stands for Field Service Operations. And so Field Service Operations is where people that need to go on site to fix some type of machinery or system that can't be returned to the manufacturer. And so this is a picture of a truck that would go on site to repair gas stations. And so you can see the gas station, the gas pump is open there. It's actually a lot of computers. Probably one of the main things they would have to do when they were repairing things was actually restarting routers and switches. But it really comes down to that they have to, in some way, these field techs, as we refer to them, the person that's kind of behind there in the orange shirt, they'd have to go on site to fix something. And there were a lot of other people that were involved in this particular problem. There were dispatchers that would help them organize their work. There were the warehouses, parts runners, managers that would have to be looking at KPIs. And in the end, we did this for Google and PwC, where they were looking at a couple different verticals. And so we had to really understand in a deep way what were the problems that they had with the current software or systems they used. And then how could we in some way improve them using both PwC consulting services, which is really around operational efficiency, and then Google apps, so things like Docs, et cetera. So that was really the framing for this particular set of work. It lasted for about 1.25 years when I was at Philosophy. And we used the design sprint methodology, I would say at least 5 or 6 times for different individual prototypes that we were building. And so some of the things we did build, one of them was a chatbot, which was named Patrick in this case, and that was for field techs to get help. There was also a field tech kind of job management app with different prediction capabilities. The screenshots you see here are basically the dispatcher workflow. So being able to look at different jobs that are coming in and then work on them. And I'll talk in more depth about what were the different types of AI or machine learning systems that we were prototyping in there. But we built a bunch of different stuff and we tried a lot of different things. But a lot of the time we didn't actually build anything in the traditional sense like an actual machine learning model. It was more about understanding how people would use these models in their day-to-day. This is an example of kind of, this is a frame of a video spot that PwC ended up creating and for the kind of deployed app for a few of our partners and clients. So to get started, we really have to go with the mapping part of the sprint. And really what this is about, especially when we talk about the very beginning part of it, is outcome definition. And so outcome definition, when it comes to the problem you're trying to solve, there's usually some end state that you want to get to. And that's why outcome is so important. And this is related to a story when I was at Kayak. And so Kayak, if people are not familiar, Kayak is a brand that really adds transparency to booking of travel, in particular flights, hotels, and then car rentals. And so when I worked at Kayak, one of the things that was really interesting about the work there was that we could do things in our mobile app where it made the process of actually booking a hotel to be very, very simple. So if you had a credit card stored with us because you wanted that type of ease of use, we could make it so that if you glanced at a hotel, we could book it for you. But the problem is that even though we would maybe increase the number of bookings, it really didn't change the fact that people were browsing, or that people, when you would do too many bookings, you would actually get a very high cancellation. And then there was another factor here, which was that Kayak was really moving from a desktop-based experience, where it was a web browser, to a mobile-based experience. But the problem is that even though there was more research that was being done through the Kayak mobile app, people were not booking more. And the reason why, in the end, was that people, even though that they use a mobile phone and they have access to more information via mobile, it doesn't mean that they have more time off, and it doesn't mean that they do more travel. So, this is the traditional hockey stick that I like to talk about when it comes to the, how people consider how every startup is supposed to go, is that you're supposed to go up and to the right. And when we talk about outcomes, generally we're trying to maximize some type of outcome, usually something like sales. But the problem with that, right, is that it's not always good for people. So this is a clipping from the Netflix CEO, Reed Hastings, really talking about the idea that the main competitor for binge watching on Netflix is sleep. And he also added that in the end that they're winning against sleep. So is that a good thing, right? You could also pull the case about Peloton, which is a service that has connected exercise bikes. How much time on a bike is actually good for you? Even though some exercise is good, or a certain amount of exercise is good, not extreme amounts of working out is good for you. And I think people like Apple, Google, and others have started to understand that even though you can maximize something, it doesn't actually mean that it's good for people based on all the other things that they need to consider in their life. And this is related to the idea of a therapeutic index, which is something at Philosophy. I did a few projects for pharmaceuticals, but below a certain level, it doesn't help you at all. And above a certain level, it becomes very toxic or could kill you. So I think that's true about any of these types of things where we're looking at outcomes for machine learning algorithms to consider. We need to be really aware of that. And that's because machine learning doesn't care, right? Machine learning doesn't have the value set that we have. And so being able to decide not just one outcome, but multiple outcomes that you need to coordinate is really, really important from that standpoint. So that's really outcome definition. I think that's maybe more of a warning than anything. So the next thing is Monday afternoon is really about talking to experts. And so when it comes to understanding the particularities about building an AI or machine learning system, understanding things for the people that will use these systems is incredibly important. And so, the question is who are we talking with? And when we start to refer to things like AI in organizations, there's a couple different models that are generally considered. So this is one in a Medium article by Chen Hao Tan talking about the idea of a human in the loop type of system. So results are sent to a human, the human then gives feedback. It could be adjust labeling, things like that. And then the machine does the final kind of result, right? That's a traditional human in the loop type of system. They've also talked about the idea of a machine in the loop, which is more assistive, right? Humans give context, or there's context available, and then machines give a suggestion, the human takes the actual final action. Beyond that, though, we start to get into this idea that there's more loops than just the single loop of the human and the machine. And so this is a slide from a talk by Brad Klingenberg, who I believe is still the VP of data science at Stitch Fix. And so I use Stitch Fix a lot. If you're not familiar with it, they send you basically a box of clothing once a month with 5 articles, and then you decide what to keep and you send it back. They use a lot of machine learning systems to be able to do better prediction of what you would like, and then do things like fulfillment within warehouses, inventory, and then even the idea of generative research to be able to say, what should we be making next as far as a white labeled clothing garment? And so, but there's not just one label. This is a system where there's a human kind of stylist that gets a list of recommendations from a machine. They say yes or no to the things, and then the shipment is sent to the end user. But there's not just that, right? There's the warehouse and how they do fulfillment. There's the idea of what articles to build. So there's multiple loops that are involved here, not just one. And I like using this. This is actually a graph network of interactions in Star Wars. And the reason why I use this as a reference is because some of these systems, some of these things here, some of these nodes are actually not individuals, but actually machines, right? And when we talk about AI in, say, a business context, it's more about the ecosystem of machines, right? It's still humans trying to do things with other humans, but there's machines or AI systems or machine learning systems that are intermediaries in that entire network. And so it's not as simple as just one human in the loop anymore. And this is actually a scene from War Games, which was a movie in the 80s. Basically, it's about this machine called the Whopper, which is a supposed human out of the loop system. And what ends up happening is that it controls all the nuclear arsenal for the United States. And spoiler alert, it goes a little crazy and almost blows up the world. And what's funny about this, or I think interesting about this, is that there is no such thing as a human out of the loop system. And that even though this system was built to make its own decisions in some way, it still would have affected everybody in the world, right? Like even though, even if we start referencing things like autonomous weapon systems in general, there's still someone being shot out, even if there's not someone making a decision to actually pull the trigger. So we need to be aware of that it's not always just the people that are, say, operators of these systems, but they're the people that are in order affected by these types of systems. So I just want to make sure that's clear, that there's no such thing as a human out of the loop system. There's always a human somewhere involved somewhere. And the reason why we don't always understand that is because we don't draw the system boundary correctly, right? So a lot of the time, especially why design thinking or just, sprints are really important, is that you are actually considering everybody that's involved that could be impacted based on what you understand. So in this example, right, there were a lot of different people that were actually impacted in our particular field service operations. It wasn't just the field techs. And we ended up expanding our system boundary until we included dispatchers, the other employees, and even customers and clients, and then the clients of those clients to basically build an understanding of how we could impact them. And this allowed us to actually do a better job of servicing the problems in the system rather than just focusing in on what was our first kind of initial request by our client, which was to look at the field tech. And one of the systems that we used to do this is a actual picture of an early exercise that we used called Rich Picture. And Rich Picture is something that comes from soft systems methodologies of the 70s and 80s. It's kind of a post-cybernetic systems thinking where when systems thinking really came out, they would build these like very complicated structures, diagrams that would then say essentially, here's how a system should work. But the problem is it doesn't work exactly this way because of these weird things that are in these systems, and they're called humans, right? And so Rich Picture is really about this idea of you're not just looking at, say, the structure of the environment based on system diagram of the architecture of different systems that interact with each other, but also how are humans in some way integrated in that. And so you can see here, the Post-it notes are kind of sketches of individuals like field techs that are in this system. But it was a co-creation activity that we used to understand all of the different systems, including like actual software, different types of infrastructure, organizations, and then the people that are involved. And so I think this is a really, really important exercise as far as Rich Picture to be able to use as a co-creation exercise with the people that you're trying to solve a problem for to understand the entire context. And so that's where one of the things you'll see here is you'll see like individual little like things that look like red X's. Those are places where there's conflicts in some way between the different agents in the system. And that's where there's a real opportunity to solve a problem by either automating something with machine learning or AI, or recreating the interface by which that happens. So I think that's a really effective exercise to use. And then, finally at the end of Monday, right after you've talked to experts, after you kind of understand the outcomes you're trying to get at, it's really just about problem selection, right? And which problem this week are we going to solve in some way? And so this is a link to a Medium article by Google's Pair, which is really about human-centered machine learning. And the fact that I just like to bring up is that machine learning does not actually help you decide which problem to solve. It'll give you information and will help you do pattern matching, generalization, but it's up to the human beings to actually decide what is the right problem. And one of the exercises that we do to really frame this problem is called the how might we. Now, this is something that is used in both the IDEO's version of design thinking as well as the D-School version of design thinking. But I think it's really, really powerful even in the design sprint process. And so how might we is really this idea of, how might we help a particular person, and then framing that problem so that we're not just going in a million different directions during the sprint, especially if we're trying to apply technology like machine learning. So in the case of the how might we, and that's abbreviated a lot of time by HMW, for this particular case was how might we help our dispatcher, remove the complexity associated with scheduling, service, and construction field tests. And so this was like, really at the end of the day, we agreed as a team that this was the particular problem that we were going to try to solve and actually create a prototype and then test by the end of it. So that's map. That's like the Monday, right? The next thing is now Tuesday, which is really around sketching. And so there's some things that I've done that I think are really valuable in this case. So sketching really comes down to the idea, how do we get ideas to solve this framed problem that we found in the how might. And so one of these processes that I've used an awful lot is something called Crazy Eights, okay? At Crazy Eights, this is what a Crazy Eight looks like once you've done it. It's basically you take an 8.5 by 11 piece of paper, you fold it up so that there's 8 sections, and then you have a timer. You have everybody in the room that you think would be valuable to help create ideas, and that could be engineers, designers, product people, managers, even customers potentially. And you have everybody sketch their own thing privately, quietly, over 8 minutes, and they have 1 minute per sketch to get through, basically. And so you can see here, my handwriting is really horrible, but this was for a particular interface around scheduling, I believe, and for the Joes. Sorry, the field techs in this case. We gave them all persona names as well, by the way. I'm not going to go into personas very much, but I'm happy to talk about that. But what's really interesting about this is, and what we've used when it comes to trying to understand what are the pieces or components that are important for this particular solution. And so we use different prompts for each one of these things. So the 0th prompt is really just like, how might you solve this, right? It's how do you as an individual think about solving this particular problem, not really constraining yourself in any particular way other than the how might. The next thing that we did is we would utilize things like this particular deck of cards, and I have the deck in my backpack as well, but this is a deck of cards I actually ended up helping create that was specific to machine learning. And so what you do is for each one of these spaces on the design, this particular Crazy Eight, you'll draw a different random card from the deck to be able to consider a different question that you wouldn't have considered otherwise, right? Because the biggest problem here is that you're constraining yourself in some way to what you currently think about the problem. What you want to do is you want to consider more than just that. And so in the case of these machine learning cards, right, what if its performance changed depending on the context? Or what if it made something fair to all individuals? Or what if it acted as a personal assistant? These are all questions that will help you kind of expand the types of ideas that you're considering. And so anyways, we would draw a different random card for each one of those frames to be able to get people to think more in the idea of like how to utilize the nuance of machine learning systems. So in this case, like, what if it took care of the small tasks? What if it reacted to nonverbal communication? What if you could talk to multiple people at the same time, et cetera. And then, I would always ask as a second to last prompt is what is a bad way to solve this, right? So this gets into a lot of other stuff I talk about separately as far as adversarial product management, but something to consider is this idea of like, what is a bad idea to really understand the edge of this? And then the last prompt I would usually always ask is really what is an unethical idea? And the reason why is because you have to be very upfront. And actually this takes place more on Wednesday than it does on Tuesday in the design sprint methodology. But how do you really understand how these systems impact people in some way that can be either biased or ethical? So I think that's really important. I'm not going to dive into too much around that, but I want to at least mention it. There are other types of sketching, though, for AI and machine learning projects, right? So this is a workshop that I've called kind of empathy mapping for the machine. And so empathy mapping is where you get together with a group, your team, again, multidiscipline, to write down and brainstorm all of the different ideas you have about the potential customer or client that you're actually building for. And so in those cases, you want to understand, like, what are your assumptions about what they do, sense, say, think, and feel? And I turn this around to say, like, for all the different ways that this machine learning or this like intelligent system could do, sense, say, think, and feel, what are all the expectations people have for that system? Rather than getting into the nitty-gritty about like, how does this algorithm actually work? It's more thinking about like, what are all the different ways that this system needs to interact with the outside world? And so that's empathy mapping for the machine. There's a Medium article that I've written about it that you can check out to understand the process. So that's kind of sketching, right? These are a bunch of different ways that you get out all the ideas, but it's really important to do that in a way that is not just brainstorming in the classical sense, but like, how are you allowing everybody on the team to contribute ideas to the possibility? The next thing is decide, right? So decide is you have all these ideas. Now you need to figure out where you're going to prototype on Thursday, so you need to whittle it down to a certain set. And so decide, this is really about convergent activities. And one of the things that I've done as far as a convergent activity is something I'll call confusion mapping. And so this is an example. This is from the Google Human-Centered Machine Learning article, but I like the animation. Confusion matrices are something that we use a lot in machine learning algorithm analysis to understand how well it's servicing something. And so basically the way it works is that the reference is really what is the truth about the world that we understand. And then prediction is what is the machine learning algorithm doing. And so if you have the upper left-hand corner, the bottom right-hand corner, it's that it thought it was true and it was actually true, or it thought it was not true and it was actually not true. And so that's true positive and true negative. And you want to understand, basically those two things help you build your accuracy understanding of the machine learning algorithm. What I think is really interesting and what we need to be getting at when we start to understand what we should be building and converge down to what we should be testing is really about these false positives and false negatives, right? And false positives, false negatives, when we talk about something like automotive, so like the idea of a true positive would be that the car system thinks there's something in front of the car and it slams on its brakes to avoid hitting it. And a true negative would be that it doesn't think there's something in the car, so it continues with regular operation. A false positive would be that it thinks there's something in front of the car, so it slams on its brakes, but there's nothing there, right? And then the false negative would be that it doesn't think there's something in front of the car, and so it just drives through it. And so there's very clear difference in the impact of those two different things. And so to me, it's really important to understand this and to start to get ahead of this when it comes to how you're defining the things to look at. And so, so I think one of the things I did is when we talk about confusion mapping is again that ideation across everybody. What are the difference in like not just true positive, true negatives, but what are the differences in false positives versus false negatives for the system? And how does that possibly impact as far as the severity, our potential users in this case. So based on what we know about them. And then what you do is you basically create a stack rank list of what is like the worst severity that you need to worry about. And so I think this is incredibly important to create that stack rank list. And the reason why is that when you start to think about how you implement these things, if it's something that is incredibly dire, you would build additional systems that are either heuristic based, ensembles of models, things like that to be able to mitigate those problems before you get to them. And so that's a really important exercise, I think, during this thing is to really understand what are the possible problems that can come out if the system does not work as expected. And that's because it will always not work as expected, right? That's machine learning algorithms in general. There will always be some way that they will be wrong because they learn from the environment. And they will not always have enough information to perfectly predict the future. That's just the reality of the world. And the next thing is accountability, right? So I think this is a great video of, let's say this was an autonomous vehicle, right? And it was trying to make this exit. So you can see that that truck didn't hit it yet. It's still trying to make that exit. And this other truck is slamming on its brakes. All right, thankfully that car made the exit, right? And it didn't get into an accident, right? So I think this idea of accountability is incredibly important. And so how is it that the systems we build actually impact other people? And in this case, even though the car didn't get into an accident, it actually caused accidents in some way. And so, you know, this is a really great paper by Elish, who's at Data and Society here in New York. But this idea of moral crumple zones, in that when we start to automate things, humans become basically the point of blame for these systems rather than the systems that are being built. And I think that's incredibly important to consider. This is another example of a Thurrock 25, which was a radiology machine for just, you know, basically giving radiology for cancer patients. And the problem was is that at some point, the system software on the left was updated. There were then changes in the new hardware on the right, and they ended up actually having a few people die through overdose of radiation. And the reason why was because the correct error was not being given to the operator of the system. And they didn't think that actually radiation was being administered to the participant. And so the question becomes like, who's actually to blame here, right? Is it the software writer? Is it the hardware manufacturer? Is it the operator? And so I think one of the things that we need to consider is how do we as people that are building these systems take accountability for what we do? How do we react? How do we not only think about this ahead of time, but how do we react in some way? And then finally, this is just a reference to an article in The Verge about basically Medicare, Medicaid systems within the United States going to expert systems that then would change the type of benefits that people would get. And the problem is that there was no way for people to disagree with the system, whether they were a caseworker or the person receiving the benefits, they couldn't disagree. And so what ended up happening is they had to take them to the Supreme Court of their states. And a lawyer in this case said that there was a mistake and that they had to update the calculation in some way. And so this gets to another thing that I think is really important about these systems when we start to consider which systems we should be building. How do we define, how do we actually decide what to build? Is we should also consider the fact that people need to be able to walk away from these systems, right? Some of the biggest abuses when we talk about machine learning systems in general is that people cannot opt out. And so I think that's really important. And when we talk about ethics, I think there's like a really great article here about kind of the 7 traps of AI ethics. And the one that I think is most important is really the 5th one, which is the dichotomy trap, is that the goal of an ethical reasoning is to become ethical, when the truth is that it's really about a process in some way. So I would recommend that everybody reads this article in general. I think it's a really great one. And the reason why this is important is that it's not about the endpoint of having a system that is signed off as ethical, but what is the practice of ethics, right, for us within these systems? And I think that's incredibly important when we decide what to build. And so I don't think it's necessarily a code of ethics. I think that's helpful to have values as an organization, but I think it's more about what are the questions and mindsets we need to apply when we talk about deciding what to build in this sprint process as far as questions and mindsets. And so here's a list of questions I would usually ask, right? What if they could opt out? And what if we were penalized for them opting out from the system? How do we answer for our decisions? How do we include accountability? How do we explain or allow people to interpret what's going on? Are we leaving anybody out of this discussion, right? Should there be more people that are part of this discussion? And then finally, when we learn about something, how are we fixing things? What's the ongoing maintenance about? And is that possible with the system that we built? And then the next thing when it comes to mindsets, I'm not going to go into these too much, but veil of ignorance is a great one, which is if you're randomly assigned to anybody in the system, do you still feel like you have justice? Nothing about us without us is really this mindset of you need to include the people that are being impacted. Adversarial thinking is questioning assumptions, and then randomness. Like how do you add randomness to get out of the biases or assumptions that you have? So that's all I'm going to talk about as far as decide. But I think a lot of the time we put ethics at the end of the process when the reality is we should be doing ethic discussions, ethical questions in this part, right? After we've created all these great ideas, we should ask real questions about ethics while we're trying to decide what to build. So that's the decide. And by the end of day Wednesday, you'll basically have, here's what we're going to go off and prototype. And now when we prototype, I think that gets really interesting when we start to think about what does that mean for AI or machine learning systems. And so in the prototype, right, we want to understand what are we really using these prototypes to do. And so there's a bunch of different reasons why you would build a prototype. But in this particular case, one of them is about interpretability, which is incredibly important for machine learning systems. So this is the classic kind of accuracy versus interpretability, where you have things like linear regression, very interpretable but less accurate potentially than neural nets, which are more of a black box. So I'll just, this is maybe the only joke, that Twitter joke I'll show in this presentation, but this is an example of explainability, right? So the mom asks the kid, why did you kick your sister? And the kid says, because my attention was on her. And mom says, be more specific. Kid says, because of the vector. And mom's like, huh? And the kid says, C embedding 122, 01, 13, 23, 199, et cetera. So this person answered. It's very explainable. It's explainable in the sense that this is the exact reason why I did this, but it's not interpretable for that mom to now intervene and then take action to stop that behavior in the future. So I would make an argument that we care less about the true sense of explainability, which is more of a practitioner to practitioner standpoint. And when we're building these prototypes, we're more interested in interpretability by the people that are going to use them. And so this is a really amazing online book. It's free, called Interpretable Machine Learning. It takes you through a lot of the great research. I think it's awesome. So definitely go check it out. In the idea of good explanations, which is referenced in this paper by Tim Miller from 2017, is this idea of all the different things you need to have for human psychology to have a good explanation. And I think the thing that's most interesting is really this idea that we need them to not only be truthful, but coherent with our prior beliefs. And that is a real problem, because for us to actually be learning something, sometimes things have to disagree with what our prior beliefs are. So that's a very interesting problem. And I think interpretation through examples is a really key one. So first of all, counterfactual explanations. If you're having, this is Lime, which is like a interpretable model where it shows parts of the picture about why a particular classification was given. So this is like a counterfactual. There's this new idea, this is a great paper about XAI or explainable AI, but it's based on the idea that people have biases, so we need to provide visualizations or interpretability that help us avoid the biases. And in this particular case, was like a medical dialogue. So I definitely recommend this particular paper because I think it's really the future of how we start to build interpretable systems. And the next thing is about abstractions, right? So once we need something to be interpretable, we need to take whatever the true state of the system is and then make it abstracted in some way that I can understand it. And abstractions are a computer science idea. And I like to use this example, which is from the MTA, which is the subway system here in New York. And in particular, this is a New York Times article about how two particular policy decisions ended up creating a very late subway system in general. And so my question to you is like, what's the right abstraction for people that are decision makers to actually make decisions about policy? Is it this level of abstraction, which is the train driver? Is it this, which is the kind of like local switch? Or is it this, which is the command center for all of New York City? And I would argue that it's none of these, right? This is what the New York Times ended up putting together as far as a visualization. On the right-hand side is you have kind of hypothetical subway cars based on delays. And you can see in the upper right-hand corner the number of trips that are completed in an hour. On the left-hand side, you have two policies: more spacing between cars and more delays on cars that are too close. And you can see that the value space is actually not even or linear in some way. And so as a policy decision maker, this abstraction would have been way more helpful than probably the other tools that they used. And so that abstraction is really, really important when we talk about interpretability. And so how do we balance these types of complexity and usability for AI is a really hard question. So good abstractions, basically, it's easy to use, it's something I can pick up, and it's something I can learn and gain expertise in. And a good example of this from our case study was that this is basically the interface for the dispatchers, where on the left-hand side, you had kind of the state of the job that was ready to be signed or not. And then the right-hand side, we had a conversation that was taking place to not only the dispatcher and the field text, but also a chatbot. Now, what's interesting is that in our prototype, we were testing the 94% metric right there. So did people understand that if we said that there was a 94% confidence to schedule this job, and in particular, it would not cause a visit again, because that was the important part, is that we're not doing second trips. Did they understand what to do now? And the problem is that at 94%, they maybe understood, but once you started to 80, 70, 60%, they had no idea what that confidence score meant, right? And so what we started to do is that through our user testing, we found this out through this prototype, and then we created an updated version that was less about the confidence scores and more about the next things that were important to do. And so that's an example of like where abstractions in some way can be helpful or actually not helpful. And finally, I like to talk about a few UX patterns when we talk about prototyping in general for these types of machine learning systems, right? So one of them is really assistive. So how is it that we're helping people avoid mistakes? How are we helping them do something where they're the main actor? That's really the kind of machine in the loop type of system. How are we doing automated or agentive technologies? How are we allowing systems to go off and do things and then update us when they're done? And this is a really great book by Christopher Nacelle, which is about kind of like designing agentive technology. I think it's a really great book if you want to read up on this type of thing. The next thing is generative. So not only can these systems basically help us avoid errors or go off and do something for us, but they can help us be more creative as well. So this is an example from AutoCAD where they give a set of constraints for the stress. And then what they do is they use genetic algorithms, which is a type of AI, to actually evolve towards a more efficient and better example. So you can see here, the left one was designed by a human, which is very straightforward, very kind of like certain of its understanding of the world. And the one on the right is actually computer generated, but still built to withstand the same type of pressures, but using less material. And then finally, I think this is kind of like a crazy idea, but the idea of like animistic really refers to this idea of spiritualism from Native American populations or Shintoism in Japan. It's really about that every object has a spirit. But I'm really using this as an analogy for the fact that when we start to design how we interface with systems, how should we expect this particular thing to work? And I don't mean our computers, but I mean like, how should the lamp in our home work? Should we be able to talk to our lamp? Should the lamp answer back with anything more than a state of a light being turned on or off, or flashing or dimming? And so I think there's something really interesting here when we talk about experience, is that it's not just straight up people talking or status lights or things like that, but how would we expect this system to actually operate if we believed or we personified the way that system would work based on our expectations for it? And there's also non-coded and coded prototypes when we talk about AI machine learning. So first of all, when we built this prototype, we didn't build any of this in web technology. This was a sketch prototype that was loaded into Envision. And then just given to different dispatchers to be able to try out. And really, all I'm trying to say about this is that there's the idea of a Wizard of Oz type of thing where you have maybe facades that are created in some way where it's actually still a human in the back end. So that's one type of prototype. And this is a great example of that by Dr. Wendy Ju, who used to be at Stanford and now is at Cornell. But this is an autonomous trash can that kind of goes around and tries to get people to give trash. What's interesting is that it's actually puppeted by someone off screen that has access to cameras, and they're able to see some interesting behavior here where this person is ignoring the trash can because it thinks that it's looking at him, and then when it turns around, he looks at it. And so this is like behavior that if you had to build a fully autonomous system, you wouldn't necessarily understand this type of behavior. But by just building a puppeted system or a Wizard of Oz system, you can do this. And this is an example of like where Wendy, Dr. Ju is now doing a lot of interesting things with in-car types of systems by this Wizard of Oz kind of system through Alexa in the car. Same thing, this is a Art Center prototyping system that does the same thing. Next one is concierge. So how do you have that the human is really up front, but allowing for machines to be the ones that are on the back end, providing them with the answers? And so an example of this was that we used WhatsApp as far as a way to communicate. There was a particular job we were doing for Sky Mexico, where they do a lot of door-to-door sales when it comes to satellite TV. And so rather than creating a web page or something like that to basically for these salespeople to crunch the numbers to say what were the best houses to go at to do a sales process, we would actually just send them this information via WhatsApp. So it looked like it was coming from an individual, which was someone on our team, but it was actually a model that we would build overnight that was very, like in this particular case, very manual, but then we would provide it to them as a human being. And so we were able to test not only the interface, like, is this the right way for us to do it, but also the actual metrics, things like that. And it really is about faking it while you make it, right? So this is an example of in Amelia, which is our conversational agent. We use a kind of WYSIWYG type of system for the dialogue flow. So you can see here, there's like say and ask tasks, there's a request to document, but basically we can use the same system that we would use to build very complicated or complex conversations to build out something that is very linear and kind of just is able to test out whether the conversation makes sense. So this is our web chat experience. So you could see what it would look like if you were to do this. So that's something that I do a lot to kind of just like mock up for our potential clients. What would it look like to have this type of conversation? Does it make sense? And then finally, it's like prototyping with data, right? This is the data and AI landscape for 2018, and 2019, I think, just came out, but it's even more. So you basically have a huge number of options when it comes to, say, you need to do image analysis. You have like 10 options today. So I would say like one of the things that I've done previously when it comes to prototyping data is that just to see whether I can get anything better than random with tools that are off the shelf. And if I can't, then I have to have a real question about, do I have the right data? Do I have the type of, are machine learning models state of the art kind of the best thing? You know, are we able to do the thing we need? And so one example of that was around imagery, where I tested out a lot of different systems just to see if I could, you know, based on a photo of a digital system like a TV screen or a computer, where I was looking at art, could I identify that art doing reverse image search? And I found that it was actually pretty hard for us to do things off of a screen where the computer was in view because it would classify it as computer. So what we saw is like a real dynamic. We would have to either have people frame it, or we'd have to have a two-stage machine learning model where I would first identify where an image was rather than the computer itself, and then crop appropriately to then look at that. So that's an example of that. And the final one that I really love for prototyping is this idea of role play. So this is an example of where, I'm not sure if you can see it, but essentially it's the idea that you have a human being play both the autonomous system and the actual like human that would be involved. And so this is an example of where you give each group or each person some rules they need to follow. And this is for doing role play of autonomous vehicles. So the autonomous vehicles need to follow rules. The passengers have things to do. And so what they do is we provide a how might we prompt, and then we essentially have them role play how they get done the things that they need to get done. And it's really, really interesting because it becomes very visceral in the sense that, you know, how do they understand like the interfaces that need to be there to even call a car to come to them, right? And so that role play is really, really interesting. And then we start to throw wrenches or have like events that happen during this role play. So like the child that you picked up needs to go to the bathroom. There's a sensor failure. How do you describe that to the human being if you don't necessarily know which sensor? And then I use cards, things like what if the AV asks for human help, things like that. So those are like some interesting ways to do prototyping for this. And I think that idea of role play is really, really super low tech, super easy to set up, but provides you with a lot of really interesting information. And so that's prototyping. The last part is really about testing, right? So testing is about how do we understand trust? And this related to a startup that I did where essentially it was a Complete Seating was a open table competitor. And what we would do is we try to take these books and then turn them into dynamic booking. So it's kind of constraint optimization. There was prediction about how long people would actually spend at a table. And we'd use all this to give a much better view to the host so that they could be enabled to really give people the right estimates, things like that. This is an example. One of the problems we had, though, was that we tried to do too much of the job up front. And so this is the interface. This is like pre-bootstrap. But you can see the table assignment there. The ones that did not have the little lock icon was our algorithm suggesting a table. In the upper right-hand corner, when the now table 26, now table 31 was really suggestions of when you could actually see people of those party sizes based on the current state of the dining room. And so that was a prediction, basically. The problem was we tried to do too much. And so rather than just helping them avoid errors, we tried to do their job. And because we were a system, we ended up actually losing out on a lot of this. And this is related to a really great paper that I recommend you read by Parasuraman that refers to kind of 4 different states of trust. And so use, misuse, disuse, and abuse. Use is really the idea that you enable a system and you turn it off when you're done, right? That's the ideal case for things like automation. When we talk about misuse, it's about that people leave it enabled longer than they should. And so the example here could be the fatality for the Uber car, right? And not only did Uber trust those cars too much, but so did that safety driver, right? And so this is an example. This is from Dr. Iona Howard's lab down in Georgia Tech, where they had like a fake emergency and they had a robot in the hallway. And what they would do is the robot would sometimes take the person to the exit, but also sometimes they would just see if the person would follow it around in the room. And so these people ended up trusting the machines more than they should because probably a robot was the wrong context because they trusted it too much. And so that was misuse. Disuse is that you don't actually turn on the technology in some way. This is an example where if anybody's had the unfortunate experience of being in like a hospital, there's a lot of machinery that's in a hospital that is constantly beeping. And the problem is that nurses or people that are in a hospital are getting thousands of alerts per room every day. And so they end up just ignoring most of those alerts. And they have to figure out how they then judge whether an alert is worthwhile or not. And so this is an example of disuse where even though all of this technology has a way to do alerting, not all of it is used. And then finally, abuse is really this idea that you don't take into account the human beings that are using the system in some way. And that is essentially the fact that when you do something like design thinking, that you don't empathize at all with the person. And that's really bad because that creates systems where there's misaligned incentives, things like that. So how do we build trust, right? I think about it from the standpoint that there's some minimum bar that you need to explore when it comes to research with the people that you're targeting. And there are things that are above the bar and below the bar. And things that are below the bar are things like no state communication, not allowing intervention, things like that. And above the bar, things like interpretability, helping avoid error, making good decisions, right? But it's going to be highly dependent on the use because trust is not something that you can quantify. And people have tried. There's been lots of papers that have tried to do this, but it's very, very hard. And so how do we understand trust, right? We do this through user testing. So when we build these prototypes out, it's not just about testing correct operation. So are they able to complete the task or what's the happy path? But it's what happens when there are false positives or false negatives. We would build a flow in InVision that would show that type of thing and see whether people would actually in some way intervene. Would they feel comfortable disagreeing with the machine in that case? Also, you want to create scenarios where they have to give feedback to the machine in some way. And then finally, do they understand the state, right? And there's a bunch of questions that I like to ask, and I'll provide the slides afterwards. But like you want to be asking about trust. You want to understand whether they're interpreting the models the correct way, things like that. And so, we've gone through all of these different steps, right? Which is a lot of information. But are we done? And I would basically say that one of the things that's missing from a lot of the sprint methodology is really synthesis. And generally that ends up being on the weekend, at least whenever I've done it. So that's why we tend to do a sprint and then a jog is one way that people have put it in the industry. But really quickly, this is an example of where we did some synthesis after we had done a bunch of testing. And in particular, we had hundreds of observations, which are these pink cards, but we just took the ones that were about, in this case, the Patrick chatbot, right? And so we graphed them on a particular way where the vertical was not understanding at the bottom to understanding at the top, negative sentiment on the left to positive sentiment on the right. And anything below the understanding line was really that they didn't understand what to do. And so we need to change the prototype. We needed to update the way the system worked, or we need to do better change management. Upper right-hand corner ended up being really validation of the conversational agent, that they understood what was going on and they liked it. And so that was good. The upper left-hand corner, what we started to see this as is really, I know what's going on, but I hate it. And right. And so that's like a job security concern. At least that's what we initially interpreted. After giving this kind of case study presentation for a couple times, I started to realize that it's different, right? The bottom part is still, we need to change this in some way. People don't understand what's going on. But the upper right-hand corner is really, that's like the BS job that people have to do. It's the mundane tasks that they don't like doing and they want automation to take it away. And then the upper left-hand corner, those are actually the parts of the job that are meaningful to them that they still want to be involved in some way. And so I think that's an important aspect to consider, not just what can you automate, but what things should you automate at the job. And so we started to use a bunch of different systems, and this is like a use of transcription for our interviews. We started to create these like nuggets, which is based on some work that Tomer Sharon has done around how we pull out like little atomic units. And how do we start to do this? And we did this manually in an Airtable, but how do we start to pull this out automatically using NLP, NLU? I've built some tools out in AWS Transcribe. And then finally, like, how do we just like in the end, get this like electricity? We ask a question and then we get the answer back. And that's because evidence, when we talk about like what we're really trying to learn, are things that are surprising to us. And so it's not just about, what do we know now? And then what do we learn through that type of user research? But in the end, like, what are the things that are surprising and what are the things that are bad assumptions? So I think there's going to be NLP, NLU tools in the future. And so this may be like pointing to that. I think will be really helpful in us understanding where we should research more, whether we can find research we've already done that's applicable to a question we have. And then finally, like once you become a practitioner of sprints, you don't necessarily do this in that serial order every time. You start to remix and mix and match these things based on the questions you have. And then, my final thought, and I definitely have time, at least for 10, 15 minutes for questions, if everybody else does, but really you should be faking as much as you can before you build it. In the end, it's about that there's still a human being somewhere behind all this. And so we don't want to lose sight of that, right? We're just really building systems to intermediate between different human beings. And that's it. So I'll stop that. And if you want to get any of the slides, feel free to contact me and we'll have it posted somewhere. That's a whirlwind of information, but yeah, I'm happy to open it up to questions though now.
Chris, I'll get the slide. People can connect with you on LinkedIn in case somebody has to leave.
Yeah, absolutely. Feel free to message me on LinkedIn. If you want to post in public on LinkedIn or on Twitter, I'm happy to answer questions that way so everybody else can see too. And then happy to answer, just email as well.
Yeah, I'll come back. I think I did a LinkedIn thread, just promo saying, about this class and you're speaking, same thing on Twitter. So maybe I'll reply back. And then cool. I would like the slides for the class. So
great. Yeah, I did see one question from Ernie, and I think they just wanted like a little bit more explanation of thinking as much as you can. I guess what I'm saying is that before you go off and collect all the data, clean all the data, train models, do a bunch of stuff like that, I think you should be figuring out what is the actual like solution you should be building in some way. And that to me is why you do this type of prototyping rather than, and then through the prototyping, because you're faking like what the experience is, it means that you can then use that information to decide what data do you need to collect in some way. That's what I mean by that.
Yeah, hello, Chris. Hello?
Yeah, I can hear you. Go ahead.
We have a mix of designers and product managers, but
you cut out there for a second.
Charles, we can't hear you.
Yeah, I can't hear Charles. I guess we'll wait until he's able to get back on audio. Any other questions?
One thing I want to ask is, do you think that in the future that designers, can you hear me?
I heard, designers. What about designers?
Yeah, okay. Do you think that in the future that designers could be able to prototype machine learning applications and then hand off to engineers, just like they do today with visual tools like Sketch or Figma, like that? Because the problem we have is that we have a machine learning model that is actually the engine that runs the applications and which is standing between the designers and the front end of the application. So we are trying to see whether we can understand how this model works, to see whether if we can be able to shop models or algorithms, just like layouts today. You go into any place and you get a layout and then you start designing with content. Do you think that will happen in the future?
Oh yeah. I mean, we've played around with the idea of even just like taking a whiteboard sketch that I've drawn up on the whiteboard and then have it automatically converted into a prototype. And I've seen many different groups kind of do this. I still wonder, like, what is the real end use of this type of thing? So I think that's something that it's definitely giving me the future. Like, once you get to this point where you can like have a machine learning system analyze 1,000 websites, right, or 1,000,000 websites, or all the websites in the world. Like, if I wanted to create what is the standard like automotive sales website for B2C, right? I should be able to select what are the most common things that would be there, and then understand like, how does this test for our particular use case? So rather than me going off and building, what is the status quo and how does that fit in this particular thing? And then you can start to build interesting adversarial models where once you start to see how people interact with prototypes, you can build like, what would be the average person's usability of the site based on an adversarial like usage model, where that model is kind of clicking around on the site to try to find something, right? So there's a lot of really interesting uses about that. I think in particular, I would argue that you should not be building the model first, right? I think the model is a distraction, right? And in the end, what you should be doing is you should be understanding what is the outcome you're trying to get for your customer, what is the business impact, how does that fit into your business model? And that's maybe more of a product manager thing than a designer thing necessarily. But in the end, you're trying to figure out what is it we need to build right now. And then we go off and we say, how does this fit into their lives, right? How does this particular outcome fit into all the other things that they need to do as a human being? And then once we understand the right way for us to fit in this time, in that context, right? So who these people are, where they live, what they do on a regular basis is incredibly important in that aspect. Then we know, one, not only what are like leading and following indicators of something happening, but then that allows us to understand where do we need to collect this data in a way that's highly targeted. Like, I guess I disagree with the fact that when we talk about like data lakes or oceans or bayous or swamps or whatever, right? Like, the truth is that even though you have lots of data, it doesn't always mean exactly what you think it means. And repurposing data is actually the biggest problem with training machine learning models, right? Is that you may think that this is the data for this outcome, but in the reality, you collected it under some completely different pretense, right? And so to me, I actually think personally, you should do this design, you should do the research, even if it's a week or two. I think you're getting way ahead of what other people would be doing anyways. And then you have a list out of all this stuff, like, here's the data that we think would help answer these questions. And then the machine learning models after that come, where it's like, okay, we have all this data, here's the outcome we want. What are the right machine learning models to help provide us with that type of prediction or classification or whatever, right? NLU, NLP, whatever it ends up being, right? So that's where I think it's really important that we need to reverse it. We shouldn't be, we shouldn't have engineers going off and like grabbing some data and then shoving it into a model necessarily. We should be making sure we understand the outcome we're trying to get to. And then we start to experiment with not only the interaction UX elements of things, but also like, I think that's an appropriate time to see like, what data do we have available based on what we feel like we should be building? And is it actually the right way to interpret that data? Or are there going to be problems or biases that we would see in it?
That's really very interesting. I think I enjoyed the where you talked about the confusion matrix and the interpretability.
Yeah, it's a great tool, right? And I think we do not ask enough questions about like what is really bad to be able to understand that, right?
Yes. I think you have another question on the chat.
Sorry, someone was trying to taunt me with a sandwich outside my window. So yeah, so what would be the right approach, coded, prototype, or non-coded when it comes to designers from non-tech background? How tech savvy designers need to be? I think actually it's not your job as a designer to be tech oriented necessarily, right? Like, it always helps to have background or something like that. I think what you need to be doing is designers need to help provide trade-off conversations with engineers or data scientists about what information. So say an engineer says, like a good example of this, right, is that with the internet, there's a lot of tech stuff that needs to happen when it comes to assembling a web page, right? Or how JavaScript works, or even getting down to the idea of like, no one knows how the actual like protocol layer, like TCP works anymore if you're authoring a web page, right? That's okay, because you don't care. Like, that's not actually important in building a web page anymore. But it doesn't mean a designer necessarily has to know the explicit way that like a particular website is built, because it's more about how are they talking about the right type of interface or experience, and then having that conversation with the engineer to have trade-offs. And that the designer would say something like, I really want it to be like this. The engineer would say, well, that's going to be hard because of these reasons, but here's other options that can get us closer to that, right? And same thing with product. It's like, how do we prioritize all these different needs in some way that is getting at the core of what we're trying to do? And so I just think it's very, very important that we don't I mean, I realize it's a little unfair because I'm a product person that has an engineering degree, and I still can do, and I still do development. I would never pay myself to do development. That's not my job anymore. But I think it's important that it's not my job to tell an engineer how to do their job, right? It's my job to ask them the right questions based on the domain of expertise that I bring as a product person. And it does help in some ways for me to have the shorthand of technology discussions so that the trade-off kind of discussion or conversation actually goes by faster. But I would say that for most people, I think it's about how you create tension in these teams where everybody's pulling in different directions, but we're all agreeing on one thing, which is the strategy of the organization. And so I think that's when you really create things. And this is like less specific about AI or machine learning. It's really just about how do you build great technology, in my opinion, for people.
Yeah, I mean, because these days you talk about MLUX, and many designers say, "Oh, that's not for me."
Yeah, exactly.
Everybody's scared to like jump on the conversation, but we can't really actually leave the design of AI to.
That's exactly right, and that's why like the confidence score is a great example of that, right? Because you do get out like as part of whenever you're doing say classification, you're getting kind of a confidence score based on the training that model got for the data it had access to, right? And so the reality is though, or the problem there is that that's a confidence based on the data it had, not the truth of the world, right? And so it's not confidence or uncertainty in the way that regular people consider that. And so that is the biggest issue, really. So I would say like, that's why designers need to be helpful in like, how is this decision being framed to someone so that they can make the right decision? This is why like, whenever I see someone say dashboard, I kind of roll my eyes. Like dashboard is not a feature, right? What you're doing is you're building something so people can make a better decision. But if you just call it a dashboard, that's like, I'm just going to throw some numbers on a screen somewhere and it's gonna be fine. You know what I mean? Like that's not okay. Like what you need to be doing is this dashboard is actually a decision-making feature. It should be called something else than a dashboard. And so anyways, that's maybe a little bit related in the sense that like, you don't want to just be like spitting out, here's the top 5 with the confidence scores. That's not necessarily helpful in the context I need to make a decision.
Yeah.
Chris, you have to leave. I know it's close.
No, I have a few. I mean, I'm okay for a few minutes if people are okay, but yeah, I totally respectful.
The students have question. I want them to ask first. Yeah. I have a question, but I can wait. Anybody else have any questions? Do you see any in the chat window?
I don't see any more.
Okay.
Yeah.
So I have a question. This goes back to the evolution today of, you know, the researcher building the model, the PM doing their PM thing, and then the designer doing their design thing, right?
Yep.
And I loved how you put that you need the healthy tension to make that happen, right? What I'm seeing mostly working with autonomous vehicles and the like is there's a lot of new models being developed, a lot of need for models even being, you know, coming from the engineers. Saying, hey, what they imagine a customer use case, which is kind of the end point, and then they go build a model. So my question is, when you practically do this, I love the process you gave multiple examples. The model that you start off with is predicting and is not ever 100%, right?
Yeah, so, I mean, I think this is where like the reason why groups like Google really spend an awful lot on simulation technology, right? And that's why like there's this like strong convergence over and over again of like machine learning and video game people, basically, like not just because of the GPUs that these things run on, but the idea of simulation is really important because the complexity that an autonomous vehicle needs to exist within is actually the context on the road, right? I think there are other people that are talking about the idea of what is it like for the passenger inside, which is, you know, there's a lot of issues around like queasiness, like how jerky of a motion you can do. So it's about satisfying these different things. And I think what's really interesting is that because driving around is a very complex behavior, right? There's a lot of emergent things that come out of it, like traffic jams, accidents. These are emergent behaviors, right? So what you need to be doing is, especially when we talk about a new model, there's still an outcome in some way. Right? The outcome is that you don't want to crash into people. You don't want to hit people. You want to obey traffic laws. You want to get people from point A to point B. And so it's about, you know, this combination of like satisfying all these different kind of outcomes in general to be able to meet the end goal. Now, when we talk about the idea of ensembles of models, that's really interesting, right? Ensembles of models, that's where simulation really comes in, right? Simulation is really important because from that standpoint, I can then see, I think this is one of the things I didn't talk about in this talk, but it's the idea of like intersectionality, right? Intersectionality is this concept from kind of the 70s in the feminist movement, but it's the idea of like that, and there's some great work by Google and Jigsaw around toxicity on the internet. But basically what it comes down to is that even if you get like high 90% accuracy, there's still a small percentage of people that you're not servicing correctly. And so in those cases, you need to then create maybe more specialized models. And those are ensemble models or gating models or something like that. And so in those cases, if, for example, in a simulation, you're seeing that you're failing for some small percentage, that's where you need to consider, do I need to collect different data, right? Do I need to prototype different interfaces? So that's why, like, I think Nissan has talked a lot about, like, how do you actually provide state through the external, like, displays on the vehicle, right? So there's all these different things you need to start to worry about when you talk about the smaller percentages, and that's why confusion mapping, I think, is so interesting. So at the end, like, yeah.
Sorry to interrupt. So
No.
the examples you're giving us of the actual car cognition, how the car drives, we are looking at the in-car experience where there's a lot of things made up. This is how the customer wants. The customer doesn't want a wheel. The customer wants voice, a lot of combination of shared space experiences. So I'm going back to somebody is building a model. That seems like the starting point today in how most of these happen. And then people like you or Charles come in and say, hey, we are going to do design. We are going to do product management. We bring the customer to the center of this, right? So when you're getting feedback from the customer and there is a need to go back and iterate and build the model, how does that work? So do you iterate the model? Is that a conversation you have in-house about iterating the model? Or do you
first of all, we share, I mean, we do the research, right? So we would still build some type of way to test whether this matters, right? Like, or how does this matter to a person? And so that could be a simple prototype, could be a cognitive prototype where we ask them to like balance different things. But then in the end, it still is that we know that we need this action in this particular circumstance to be different in some way. And that would be then the framework that I would provide to someone that is a researcher or an engineer that would then start to look at the data types they pull in and how does that impact the actual behavior. So it's more important to me to get to that, like, what is the outcomes that we're worried about in this sprint or whatever? And then how are we not adhering to that today? How do we think that would impact people? And then from there, that's when we start to decide what data do we need? And then how does that plug into the rest of the systems in some way? So, but I think what's important is that we include engineering or those research scientists into that beginning of that process, right? So research is not secret, right? It should be published to everybody. People that are engineers and designers or managers should be able to view any of the research as it takes place. And they should be able to provide questions that they have as well. Now, I think there's like, when people first start doing user research, for example, they tend to ask very priming or biased questions. And it's not their fault, it's just the way that we think about things. And so I think it's more still, we need a guide, like there are research specialists that do the right way to ask these types of questions. So I think that's still important for them to do that as a core. But I think all of this information and this entire story is with engineers as part of it. It's just that they're not actually picking up their command line tools or like authoring tools until later in the process, once we've been able to identify what is like the right way to kind of fix this in some way.
So I guess, I mean, I don't want to throw jargons to the class, what they've not learned, but I'm going to, what you do as ML optimization and find the gap back for the engineers. But I'm looking at designers or people who interact with customer research to go do that.
Exactly, so, that's right.
Yeah.
Yeah, and they'll, I mean, there's two types of research, right? There's generative research, which is more like, what problems do people have, right? And that's very important research. It's very open-ended. But then there's incredibly particular research, which is more usability, right? And so Dr. Wendy Ju, that's at Cornell now, does an awful lot of this work. She did some really great work at Stanford where she wanted to test to see whether, when it was faking an autonomous system, so it actually was a human being sitting in the car, but they had like a car seat cover on them, so it looked like it was an empty car. And they put some like fake cameras on top. And then what they do is they would kind of encroach on the crosswalk to see if what people would do in that case. And what was so interesting about this study was that a majority of people didn't even notice it was an autonomous vehicle, right? Like they wouldn't even look to look at, like, there's this kind of perception that I keep hearing as like a trope that people will look in someone else's eyes when they, like the driver's eyes, to coordinate who goes first. And this is not true. Like when they would actually encroach on the intersection, people would not look up. They would just see the front of the car and they would like pause. And then if the car stopped, they would just walk. They wouldn't even look to see if the person, it's like something, I can't remember, it was a crazy amount of time. They didn't even notice there was no one in the car, basically. And so anyways, I just think like that's really interesting research. And that's the way that you do like usability of how cars like make their way through an intersection, for example, right? That's really interesting work to do.
It's fantastic. Is there any other question, or we should let Chris go? It's lunchtime he just finished his lunchtime, gave it to us.
No problem.
That was very interesting, Chris.
Yeah, great. Well, thanks. I've definitely email me, LinkedIn, Twitter.
We'll definitely follow up. This was fantastic.
Thank you.
Thank you so much, Chris. Bye.
Bye.
I'm going to stop the